Section 1, 2, and we are going to be talking about and reviewing the concept of a function, domain, and range, and piecewise functions. You should be on page 3 of your packet. All right, if you want to take a second here and pause the video and write down these definitions, I will run through them here for you. A relation is a set of ordered pairs or quantities that are related to each other. Domain is always the set of all x values or input values. Range, the set of all y values or output. And each element of the input is assigned to exactly one element of the output. That's what a function is. A function is when you have one x and every x has exactly one y that it corresponds to. You can't have any repeated x values in order for something to be a function. All right, this is an example of a relation right here. Here is our set of ordered pairs. And our set of ordered pairs can be represented. There's several different displays. They can be represented in a table, in a graph with plotted points. And then this last one here, this last one's called a mapping. So we've got 4 different ways here that we're showing the same relation, a relationship between two quantities. Let's look to see whether or not it is a function. If you look at your table of values here, your x's, you can see here that 2 is being repeated, 2, -6, and also 2, 2. Well, that can't happen in order for it to be a function. You can also see here that the ordered pair 2, or the x value of 2, has 2 different y values directly above and below each other. Again, that fails the test. And then you can see here that it's mapped to 2 different y's or 2 different outputs. So this is not a function, but this is a different, several different ways for us to represent a relation. All right, here's our ordered pairs, or our set, our relation. So if we're asked to find the domain of that, the domain is just the x's. So we're just going to list the x's. And we typically will list them in order from least to greatest, -5, 1, and 7. That's all you have to do, just list the values that are in the set. Range would be the y values. Again, least to greatest, and you also do not need to repeat any of them. So 3 and 4, those are all the numbers within that set. Is it a function? So we're going to come back here and determine you have a 1, a -5, and a 7. They're all different. So yes, it is a function. Okay. We are still on page 3. Now we're going to go ahead and look at example 2. Here's the mapping that you see there on your page. We're going to go ahead and look at the mapping and determine these parts. So what is the domain? So domain would be, again, all of the x's. You do not need to list them any more than what they exist. So 2, 3, and 5, that's least to greatest. And range would just be 3 and 7. Is it a function? No. Here you got 2 and 2 being mapped to 2 different values, so no. All right, example 3. Which of the following equations represents y as a function of x? Y as a function of x is an equation where it's y equals, and your expression here has an x in it. Okay? Let's solve for y. So if I solve the first one for y equals, move the x's over, doing inverse operations, and you get +1 here, -x² + 1. Is it a function? Well, there's a couple ways that you can do this. Let's look at the graph. What does this look like? Okay, so we know it's a squared x, so it's a quadratic. Quadratics are U-shaped or parabolas. This +1 shifts the graph up 1, and the -x² makes it open down. So this is what it would look like. Obviously, we don't see any values of, each x value has a different y value. It passes that vertical line test that we use. So yes, this is. Another way that you can look at it is if you just put in x's here, if you put in your own x values or input values, you'll always get a different y. There's never going to be, like if you put in 5 here, you get one y value coming out of it. You'll never get two different values. All right, we need to solve this second one here, letter B for y. So you do y squared. If you add the x over, x plus 1. And in order to get y by itself, we will take the square root of y. So take the square root of both sides. When solving, anytime that you have an even index, square roots, fourth roots, you always have to do plus and minus. Now, the problem with this is that whatever I put in for x, let's say I put in 3. If I put 3 in, you have plus and minus the square root of 3 plus 1, plus and minus the square root of 4. I get two different answers, plus and a minus 2. So this is not a function. I put one x value in of 3 and I get two different answers. So this is no. Letter B is no. Okay. All right. The next thing that we're going to do is review how to evaluate functions. Evaluating functions just asks you to take whatever the number is. This is asking us evaluate the function g at 2. So 2 is your input. So that would be negative 2 squared plus 4 times 2 plus 1, and we evaluate that. This would be negative 4. You've got to do order of operations there. Plus 8 plus 1. So 5. 5 is my result. This second one here, evaluate the function for t. So t is your input. That's what you put in for all x's. You're going to see here once I substitute that in, there's no operations to do. We're just really changing the variable. So there you go. All right, on this last one here, we're going to substitute. So here's my input, x plus 2, negative, parenthesis, x plus 2. We have to be careful when we get down to substituting in binomials. And when you have operations or opposite signs, such as that minus in front. So I'm just going ahead and substituting here. What do I got? This is meaning to take negative and then x plus 2 times itself. So we're going to FOIL that. You could definitely FOIL without having to show a whole lot there. And I'm going to distribute 4x plus 8. And then we have the plus 1. All right, here we go. I'm going to FOIL the x plus 2 times x plus 2, keeping the negative out in front. You get x squared. 2x and 2x together, the middle term would be 4x after combining like terms, plus 4. And then we've got plus 4x, and 8 plus this 1 was 9. All right, almost done. I'm going to change my signs here. Negative x squared because of the opposite, minus 4x, minus 4, plus 4x, plus 9. 4x's cancel. We have negative x squared, and negative 4 plus 9 is 5. That's our final simplified expression. That's how you evaluate into a function. All right, you should turn to page 4 now in our packet, and the last thing that we're going to talk about is a piecewise function. A piecewise function is a function defined by 2 or more equations over a specified domain. Right here, this will tell us where each of the functions are represented, or each part of the function is represented. So a piecewise function, you see here we've got a linear equation, x plus 1. So this equation, and then this is where it's at. It's greater than 0. And then this linear equation, x minus 1, is less than or equal to 0. I just want to show you what it looks like on a graph. So x plus 1, we graph it up 1, we do a slope of 1, and since it's only for x values greater than 0, we have an open circle at 0, and we're going to graph it going in this direction. So we're graphing x is larger than 0, so like x is 1, when x is 2, when x is 3. Okay, so that's that piece of the function. X less than or equal to 0. For the second one, my intercept's -1, but my slope is the same. But I'm going to do my slope going the other direction because this time, closed circle, and you're shading in this direction. Okay, so you can see the second piece, the linear equation, is shaded, or not shaded, but it is going towards the left, the values of x when they're less than 0. And that is it. That's a piecewise function. You can see it still passes the vertical line test. The only time that you have an x that has two different y's is when you have an open circle, closed circle. Open circle means it doesn't contain it, and closed circle does. Okay? All right, here's how you evaluate into a piecewise function. You need to determine which piece do you put the -1 into. Do you put it into the first line, or first part of the function, or do you put it into the second part of the function? You look at the value and you have to apply it to the domain. -1 falls in x less than 0. It falls here. So you're going to substitute into the first expression. -1 squared plus 1. 1 plus 1 is 2. Answer's 2. You only put it into the specific piece that the domain exists for that number. Putting in 0, so you have to decide where you're going to put it. Well, right here, x is greater than or equal to 0. So that means 0 is part of this second domain. So you're going to put it into the second expression, 0 minus 1, answer -1. And putting 1 in. 1 is also going into the second expression because it's bigger than 0. 1 minus 1 is 0. And that is how you evaluate a piecewise function. All right, last example says by 1990, millions of people were using cellular phones. The number n in millions of cellular phone subscribers in the United States increased in a linear pattern from 95 to 97. Then, in 98, the number of subscribers took a jump until 2001, increased in a different linear pattern. These two patterns can be approximated by the function. All right, here we got line 1, and this is between 95 to 97. You can see here that the 5 and the 7 represent the years from 95 to 97. And then the second linear equation for the years of 98 to 2001. So where t represents the year, where t equals 5 corresponds to 1995. So that's right here, 1995. This is 97. So during these years, this is the linear model that we could use to predict outcomes. It says use the function to approximate the number of cell phone subscribers for each year from 95 to 2001. All right, we're going to want to make a table. I'm going to put it up here. So we've got subscribers, number of years or time. I know that your table has X and Y, I think, or that doesn't matter. And then this is N of T. So in order for us to figure out 1995, we put in 5. 96, we'll put in 6. 97, 98.
Lauren Brotherton, please come to Student Services.
99, 2000, and 2001. So I want you to go ahead and pause the video here, and I want you to calculate this. You can see that the first 3, 5, 6, and 7 all will fall in the first domain. So you'll use the first linear equation. And then the rest of them you'll use the second. So go ahead and calculate your results after substituting each of those years into the function, and especially into each of the different parts of the function. And now these are all in millions here. And that's it. So that's how a piecewise function works, or how you will substitute. Here's your assignment for this first part to this section.